guys, in today's video we're going to be delving into the wonderful world of anatomy, and I hope you're excited. Basically, anatomy is the study of the structures and components that make up an organism. Now, how do we study anatomy? Anatomy is not actually studied by just identifying the structures and components that make up the organism. It is actually studied by understanding the functions and the purpose of those structures. Like, why do those structures exist in that organism? Like, anatomy is of two types. You have microscopic anatomy and macroscopic or gross anatomy. Microscopic anatomy is the anatomy that deals with the study of structures and components that are not visible to the naked eyes, and it is commonly referred to as histology. Now, while macroscopic or gross anatomy is the study of the structures and components of an organism that are visible to the naked eyes. And we have two approaches to studying the gross anatomy of, actually, in this case, the human body. We have the regional approach and the systemic approach. Now, under the regional approach, it involves the study of the different regions of the body, in this case, the human body, which we are going to be focusing on in our subsequent anatomy videos. So, in this case, for example, we have the abdomen and thorax is a region of the body, of the human body. We have the upper limb, we have the lower limb, and other regions. Yeah. So this is regional approach. It studies different regions of the human body, while the systemic approach studies the various systems like the digestive system, the respiratory system, the integumentary system, the circulatory system, and other systems that constitutes the body of the organism. And like the importance or like the usefulness, like each of these approaches has its own ups and downs. Like, it has its own good sides and bad sides. Now, for the regional approach, this approach actually helps us or aids us during dissection. For example, if you study a region like maybe the thorax and abdomen, when you're dissecting that region, you would have a better understanding of what you're actually doing. You understand? While for the systemic, it gives us a general understanding of the anatomy of the body, because like if you're studying it on systems, you're studying the functions of the system, what it does, how it connects with other systems and all the rest. So I believe the systemic approach gives us a better understanding of the anatomical concepts, and the regional approach is better suited for dissection. To ensure the collaborative study of anatomy, there has to be a common lens through which we all view it from. And to ensure this, the concept of anatomical position was invented or created, and by it we can now view anatomy from the same lens. In an anatomical position, the subject's eyes must be fixed at a certain object or something in the background. The lower border of the orbital rim of the eye socket must be in the same plane with the topmost part of the external auditory meatus of the ear, and the palms of the hand or the hands must be in a supine position and be facing forward, and finally the feet of the subject must be together. With respect to the anatomical position of the human body, we have three anatomical planes. We have three anatomical planes. The first one we'll talk about is the coronal plane. And the coronal plane is a vertical plane that divides the body into the anterior and posterior compartments. This is 90 degrees to the next plane which we're going to talk about, and that is the sagittal plane. The sagittal plane is the second plane, and it divides the body. It's a vertical plane, and it divides the body into lateral and medial sections. For example, we can classify various structures in the body or relate them to each other in a lateral, like using the lateral and medial approach. Like, for example, you can say that the arm is lateral to the stomach. I believe it makes sense. Yeah. So that's the sagittal plane. Now, when the sagittal plane crosses the mid portion of the body, it's called the medial sagittal plane. Now, the third and final plane we'll talk about is the transverse, horizontal, or axial plane. Now, from the name we have horizontal, so it's a horizontal plane. Yeah, and it divides the body into the superior and inferior sections. We have other terms which we use to describe position in anatomy. The first one is rostral. We could say that the forebrain is rostral to the hindbrain. Now this just means that like the forebrain is closer to the nose than the hindbrain, or like compared to the hindbrain. So like this is just a term which separates different parts of the body, of the human body or body of the organism, with respect to the nose. So any structure of the body that is closer to the nose is rostral to a structure that is further from it. I believe that's understandable. The next plane we're going to talk about is the next term is superficial and deep. So we could say that the skin is superficial to the organs of the body. Now the term superficial just means structures that are closer to the external environment, while deep are those that are further from it. Like for example, the skin is superficial to the organs, as I said before. Yeah. So now we are another term that we use is actually proximal and distal. So this actually is it deals like it's used when dealing with regions of the body. For example, the arm, you could say that the deltoid muscle is proximal to the supinator muscle, and you could say that the supinator muscle is distal to the deltoid muscle of the arm. And I believe that is understandable. Now we also have cranial and caudal. Now structures that are closer to the head are called cranial, while those that are towards the tail are caudal. To examine the different structures of the body, we employ a technique called imaging. Now, this man called in the early or sometime in the 20th century, this man called Mr. Wilhelm, he actually invented this technique called imaging. He took an image, the first anatomical image of his wife's hand, and that was the first image, I think, X-ray image ever created or made. Yeah. So now he actually invented the X-ray imaging process. I think he did it. Yeah. To take an X-ray of a region of the body, we just pass those rays through that region of the body. Now, in our human body, we have different components, and the important ones in this case are water. We have water in our body. We have air. We have fat, we have skeleton, the bone. The term attenuate just means like restricting or like stopping the passage of something. So now air does not attenuate X-rays to any significant degree. It just allows it to pass through easily. Water attenuates X-rays in a slightly significant way, like not really significant actually, because it doesn't really attenuate the X-rays much. Fats attenuates X-rays more than water, and bones attenuates X-rays the highest. Yeah. So as an implication of this, or as a result of this, when we view an X-rays, the places that contain air or have air spaces are usually very, very dark in color, while the places that has bone are very bright, very light. They appear white actually. Appear like very bright or white actually. Yeah. Now when taking X-rays of different areas of the body, we actually employ we actually use contrast agents to achieve a more distinctive image of that section or area of the body. Yeah. Now a common contrast agent is barium sulfate. Now when barium sulfate is added into the body, like we actually add these contrast agents into our body so that they can attenuate X-rays when they pass through. So like when we add barium sulfate, we actually accompany it with air. We actually add air to the body, and the result of this is that it attenuates or restricts the X-rays more than other components of the body like bones, fats, and other structures of the body. We can also get contrast agents like barium sulfate into our body by injecting them into our vascular systems like our veins and our arteries. Now these contrast agents can help us to examine those structures like the veins and the arteries and have a very distinctive image of the structure. And when it eventually gets excreted through the urinary system, which involves the kidney, the urethra, and yes, I think the urethra or urethra, whatever, yeah, and the bladder, it actually enables us to also get a distinctive image of these structures. For example, the kidney, the ureter, or ureter, whatever, and bladder. Now, many at times, bones attenuate X-rays more than contrast agents, which is really bad because it would affect the quality of the image, of the anatomical image being created. So what do? We actually just create two normal images, two X-ray images, of the region without the contrast agents. First of all, then place them side by side to create a negative image. Now, first of all, the image created without contrast agents is like a positive image, and when you make two of them and invert it and place them side by side, it creates a negative image. Now, this is just kept by the side at the corner. Then we actually now make an image of that area with the contrast agents added to it. So this gives us another X-ray image. Now we now combine the negative image plus this new image made with the contrast agent, and this gives us an image that minuses or subtracts all the bony areas of the region, which is actually very useful in making the image or X-ray image more distinctive and better for examination. Alright guys, in today's video we discussed a variety of concepts. To ensure your understanding of those concepts, I put everything we discussed in a mind map, so I would suggest you check it out. Thanks for watching. Do not forget to like and subscribe.